Practical skills are an essential part of any engineering degree. They enable students to understand physical and manufacturing constraints, contextualize the theory that they learn in lectures, which at times can be rather abstract, and produce more practical, efficient and durable designs. However, just carrying out scripted hands-on experiments does not allow students to truly harness the value of laboratory work and build the practical engineering skills that will enable them to become better designers. Students should be able to give their curiosity an outlet and be given a place where exploration and inquiry can take place, and, above all, where the value of failure as a success-enabling mechanism is understood. Constructive alignment is a well-known process. Students will only put effort into what they're assessed on. This is particularly detrimental when it comes to laboratory work, where the focus with performance rather than mastery goals is often observed. The time pressure which is inevitably put on students due to the limited lab facilities available exacerbates this problem yet further. To address these issues, at the University of Bristol, we introduced home lab kits in 2015. These featured instrumentation that enabled students to carry out many first-year practical experiments at home. Students really loved these. The removal of time constraints, the provision of many electrical components that were made freely available to them to put together their own experiments, and training videos that made starting out straightforward created a fantastic exploration ground. Based on our work on learnable lab kits that we had put through regular feedback and improvement cycles, we created new lab kits that students were issued at the start of their course in 2020 and could keep forever. These have now been further enhanced, and as of 22-23 they will become standard issue for all first-year engineering undergraduates. Simple kits of this kind, however, though powerful, had their limitations, and to empower students to truly run wild with their ideas, we also gave them access to a very powerful simulation tool that they could install on their own machines for free and used for the duration of their degree. This enabled experimentation beyond the capabilities of any of our on-campus facilities, and an insight that would not be achievable in a physical setting. For instance, taking a peek at the electromagnetic field inside a component. While the simulator featured a user-friendly and intuitive interface, we still needed to provide a number of bespoke video tutorials which were directly relevant to the material taught in lectures and enable students to swiftly learn to apply it in a virtual laboratory environment. Some advanced tutorials were also created that allowed students to go further, explore their curiosity, and inspire them to realize their ideas into interesting designs. When access to on-campus facilities became near impossible, the work that we had been doing to empower our students to become more independent and self-directed learners enabled us to adapt very quickly and thus not severely impair their learning experience. Another innovation that we have planned for when redesigning our main teaching lab in 2017 was the provision of remote labs. We created a system that enabled students to connect to a lab bench remotely and use the equipment connected to the bench PC via local network through an internet browser. While these were no replacement for physical labs and were limited to a single circuit configuration per bench, they still gave students a real feel for what it would be like to operate an oscilloscope and a signal generator to characterize a circuit. These remote labs have been very popular with students. They greatly increased the lab equipment utilization and have now become a permanent fixture. As with any scholarly endeavor, these remote test stations are also undergoing improvements informed by students and staff feedback. We thought that undergraduate students themselves would be best placed to implement the enhancements through novel final year projects which, although individual, promoted dialogue and cooperation with all stakeholders. The outcome was truly inspiring.